7C, hypothesis testing for large samples. So we're going to put together the two things that we've studied so far in this unit, which is how to write hypotheses and then how to find the probability of samples of a certain mean or proportion. We're going to put them together and do some hypothesis testing from start to finish. Okay, so remember we had our Flint water crisis example, okay, and they did a study and they found that 17% of homes had high lead, and so if the true proportion was 10%, because that was our null hypothesis, so assuming that is true, how likely is it that I would get a proportion of 17% in my sample? Okay, and so to test how unlikely this is, we're going to do a z-test. All right, two key definitions that you need to know. Number one is the p-value, all right, and this is the probability of obtaining a sample statistic that is as extreme or more than the one you got in your sample. All right, so to give you an example, we got 17%. All right, so this is all like our normal curve. Okay, because we're using z-scores. So we said that we thought, in our null hypothesis, that the true proportion was 10%. And we got, in our sample, a proportion of 17%. So our p-value is going to be 17% or higher because we always want to be moving away from the mean. So that means when we find the probability, just like we did in Unit 5, because it's the more than probability, I'm going to do 1 minus the number from the table. Okay? If our probability in our sample was lower than the mean, like let's say we got like, I don't know, 6%, okay, then we would use the number from the table because going away from the mean, getting more extreme, would be the less than probability. So that's something that you kind of have to think about and calculate each time you look at this problem. All right, second thing is level of significance, and that's, we use the Greek letter alpha here. Okay, the technical definition for level of significance is the probability of a study rejecting the null hypothesis. All right, I think the easiest way to understand this is to think of it as a cutoff value. So if I get a p-value that is less than or equal to my alpha, less than or equal to my level of significance, then that means that statistic is too unusual and I can reject the null hypothesis. Okay, so it's a cutoff value. If it's less than that number, that's a highly unusual sample, so we reject the null hypothesis. Okay, if it's greater than the alpha, then even though our sample is different from the mean, it could have just happened by chance, so we fail to reject the null hypothesis. Okay, alpha value, I'm always going to give it to you. The most common ones you're going to see are 0.01 and 0.05. Okay, so let's do a z-test for our Flint water example. Okay, these are the steps. All right, and we're going to go through them with our Virginia Tech study. Okay, so we called this lesson hypothesis testing for large samples. All right, so the rule for the sample being big enough is that NP and NQ have to be greater than or equal to 5. Okay, so let's test that real quick. So our probability was 17%. All right, which then means that Q would be, actually, I'm sorry, we're going to use a probability of 0.10 because that was our P. So we're going to multiply that times our sample size of 252. All right, and then that would make Q 1 minus P, so that would be 0.90. We're going to multiply that by our sample size, and we're looking for both of these numbers to be greater than or equal to 5. All right, and they are, and so all that The only reason for doing that is to prove that we can use a z-test. Later on in the year, we're going to look at another test called a t-test, but we have to have these numbers bigger than 5 to be able to use the z-test. Okay, identify the null and alternative hypotheses. We've talked about this in our first lesson. So our null hypothesis is that the population or the proportion is equal to 0.10, 10% of the homes. All right. And then our alternative hypothesis, what we're trying to prove, is that it's actually greater than 10% and the water is unsafe. Okay, alpha is going to be given to you in the problem since they didn't list it here. I'm going to say we're going to use 0.05 as our alpha value. All right, now find the standardized test statistic. What that means is the z-score. Okay, so just like we did in the last lesson, we're going to find the z-score, all right, for getting that 17% number. Okay, so a couple things you need to remember. All right, z is equal to our sample proportion minus the actual proportion over the standard error. Okay, and we talked about last time that standard error, okay, is equal to P times Q divided by N, and it's the square root of that whole thing. All right, so I'm going to go ahead and do that. So it would be P is going to be equal to 0.10 and Q is 0.90. We're going to divide that by our sample size of 252, and I'm going to take the square root of that whole thing. Okay, when I do that in my calculator, I get 0.019. That is my standard error. That's what's going to go on the bottom of my z-score calculation. All right, and then this part is just like Unit 5. So our sample proportion was 17%. Okay, our null proportion is 10%. We're going to divide by that standard error of 0.019, and that gives me a z-score of 3.68. All right, 3.68. That's my z-score. Okay, then we need to find the p-value. All right, if you look on your z-score, it only goes up to 3.49. All right, so I wouldn't give you a problem like this on an assessment, but I'm going to tell you that the value from the table for a z-score of 3.68 would be 0.9998. Okay, so our p-value, remember, is going to be 1 minus that number because our proportion from our sample is greater than the null proportion from our null hypothesis. All right, so 1 minus 0.9998 gives me 0.0002. All right, that is the probability of getting a sample proportion of 17% if the real average proportion of the whole city was 10%. Okay, 0.0002. Not very likely. So let's compare our p-value with our alpha value of 0.05. 0.0002 is smaller than 0.05. So we are going to reject, all right, our null hypothesis. There's no way that the proportion of homes with unsafe water is only 10%. It's got to be higher. Otherwise, it's super unlikely that our sample would have 17%. So the water in Flint is not safe. That would be our conclusion. Okay, and then we can do z-test for means as well. So just like last lesson we did means and proportion probabilities, we can do hypothesis testing for proportions and means. So let's look at an example mean problem. All right, so we have some homeowners on a street that think that the cars are traveling greater than the 35-mile-per-hour speed limit. People are driving too fast down their road. Okay, so they take a random sample of 100 cars. They find that those cars have an average speed of 36 miles per hour and a standard deviation of 4. Okay, so is there enough evidence to support the claim at alpha equals 0.05? Okay, so at 5%. All right, first thing, verify that you can use a z-test. All right, the rule for proportion is our NP and NQ thing. The rule for means is sample size is greater than or equal to 30. That is true because we have a sample of 100, so our sample is big enough. We're good. Okay, identify the null and alternative hypothesis. Okay, so null hypothesis, H null. We are going to assume that the average speed, all right, is less than or equal to 35 miles per hour. Okay, we're going to assume the cars aren't driving too fast because the claim, our alternative hypothesis, is that they are driving too fast. They're going more than 35 miles an hour. All right, identify alpha. It was given to us in the problem of 0.05. Okay, find the z-score. All right, so again, z-score, all right, x minus the mean divided by the standard error. Okay, standard error for mean, remember, is different than the proportion one. So standard error for a mean is going to be this standard deviation divided by the square root of the sample size. Okay, so we got a standard deviation of 4 divided by the square root of 100 because that's how big our sample was. All right, and when I do that, I get 0.4. So our standard error is 0.4. So in my z-score, our sample mean was 36. Our null mean is 35 divided by the standard error of 0.4. That gives me a z-score of 2.5. Okay, 2.5. So then I'm going to use my z-table. And the number on my z-table there is going to be 0.9938. Okay, then we have to decide whether or not we should do 1 minus that number. All right, our sample mean is higher than our population mean, so we are going to subtract because we're moving away from the mean there. Okay, so 1 minus 0.9938 is 0.0062. So if the actual speed of the cars is 35 miles per hour or less, and we took a sample of 100 and got a mean of 36 miles per hour, the probability of that happening is 0.0062. Again, not very big. Let's compare it with our our alpha value of 0.05. This number, 0.0062, is smaller, so we reject the null hypothesis. These homeowners are correct. The cars are likely traveling greater than the 35 mile per hour speed limit.